Hello, everyone, and welcome to the 19th episode of TechLifeSkills with Tanmay. My name is Tanmay Bakshi, and thank you very much for joining today's episode. Now, ever since I got into the world of machine learning, watching Watson play Jeopardy, for example, I've been absolutely fascinated by the world of natural language processing. And personally, language in itself really excites me. And that is precisely why I am so thrilled about today's episode of Tech Life Skills with Tanmay. Now, the contrast between how today's guest's career started and where he is today is actually really interesting. I mean, he's been programming since he was 10, and he started his career in physics, actually. He got a PhD at MIT in statistical quantum physics, but then he worked as a European patent attorney for 5 years. Now he's the co-founder and the chief science officer at Hugging Face. And in case you haven't heard of them, Hugging Face is a Brooklyn-based company that's really working towards advancing the world of natural language processing technology and making that technology more accessible to researchers and practitioners across the globe in an effort to advance what's possible in the world of NLP. Now, you may know Hugging Face actually from some of their work, like some of my favorites being their co-reference resolution system that they worked on a couple years ago, and their quintessential PyTorch package for natural language processing, and really transformers in general, called, well, Transformers. And so now, without any further ado, let's welcome the amazing Thomas Wolf to the show. Hi, Thomas. How are you?
Hi, Tanmay. Yeah, very great. It's a pleasure to be here today. Talk about NLP a little bit,
Thank
share some wisdom, and yeah, get your opinion on some question as well.
Thank you very much. I'm really glad to have you on the show today. I mean, as I mentioned, natural language processing is something that I absolutely love, and so having you on the show is really something that I've been looking forward to. And I actually want to start off by asking a question more about the sort of fundamental why we're interested in this in the first place, right? So, why is natural language processing something important? Why is it something that we should really be focusing on in terms of applying machine learning technology? What really makes it special when compared to, other kinds of data and other kinds of algorithms that we could be spending time on?
Yeah, that's a very good question, I think. And in my opinion, it's quite surprising that it's only today that we really see NLP reaching the mainstream media and being talked about a lot. I
Mm-hmm.
feel like it's just naturally the way that like we store our knowledge. All our knowledge is in written format. Wikipedia is such an essential tool for everything today. Like Google search are in text. Everything we do on the web is mostly in text. There is video and picture as well, but like text is such a core base of all the internet and all the information there. So it's quite natural that once we start to have some tools that work a little bit, these tools very quickly become very important to how we communicate, how we store knowledge, how we extract knowledge. So yeah,
Mm-hmm.
and more because just the web, the internet is becoming just increasingly important in our life, and the way we exchange information is actually increasingly in text form.
Mm-hmm.
So I think so. Yeah, I just see this becoming bigger and bigger in the future.
Absolutely. You're right. There's so much that we do nowadays that we don't even really realize. It's all text, right? I've always said that text and generally language is really what makes us unique, right? As humans, the fact that we can communicate such complex thoughts among each other and cooperate in these ways is because of language. And when we provide abilities like these to technology, right, it enables us to be able to interact with tech more intuitively, right? And open sort of that new paradigm of interaction. Now, we know why it's important, right? There's so much data out there, and we want to be able to interact with technology more intuitively than ever before and be able to use all this unstructured data that we have. But what makes it so complex? Why is it that, just now with the advent of deep learning technology, we're starting to see so much more natural language processing work happening? What are some of the inherent challenges when you're working with natural language data that you don't maybe see with as much, at least, with like visual data or auditory data? What are those challenges?
Yeah, that's a very good question. I think they're actually very different. It's actually surprising that, in my opinion, that we can even do anything at all with NLP. I think one of the most surprising thing is how dense the information is in a text. Like one byte of information, one character, or one word encodes so much information. When you compare that to a pixel, or like to if you have an audio signal to one slice of the audio, like the amount of information, it just has nothing in common. So this is one first thing that is very different. And it's sometimes surprising that we can actually use the same architecture at all, because there is such big difference between the input formats. And then another big thing is the discrete nature. Like when you have an image, you can go progressively, like from one color to the other. You can have a continuum of color. You have a continuum everywhere in the way you perceive image and sound. But in text, there is discreteness everywhere. Like you don't have a continuous path from one word to the other. Well, there is some way to do like this, to embed these words in continuous vector space, but at core space, language is a discrete field. So you have all this combinatorial explosion of possibility. Wow. Yeah, so it's actually very different, I think.
Yeah. I mean, I must say, I will agree with you that I personally found it surprising, a couple of years ago when I got into natural language processing, that the tech that we even use today, as you mentioned, is capable of natural language processing. It's almost like a happy accident. And, there are all these limitations that we see precisely because of what you just mentioned, like, for example, that discrete nature of natural language. As a matter of fact, speaking of limitations, I mean, no matter how great a source of data is, like natural language, there's going to be limitations where we start to realize what we cannot do with that form of data, or at least what we might not be able to do with technology in terms of understanding or synthesizing that data. So what are some things that you think we cannot do with text alone, where we need to start bringing in other forms of data, other kinds of techniques?
Yeah. Yeah, there is definitely things we can't do. But you probably have to see there is things we cannot do because of the way we actually store natural language, and there's things we cannot do because it's natural language. So one important thing, for instance, is the reporting bias. The reporting bias, I often talk about that, but I think it's very important. It's the fact that we often don't say the things that are so obvious that everybody knows them. We have this background of common source knowledge that everybody knows. And when you write something, you just say the special thing. You just say, "Oh, this was a special day because of this," but you don't enumerate all the common things that happened this day, that happen every day. So there's a lot of things that are lacking in just textual data, because we try to communicate in an efficient way together, and because we also a lot of the way we store natural language processing is actually communication that we store. So we store Reddit thread, we store like thoughts on your blog, and we store also on Wikipedia. So this is something that is a limit, but that's something you can fight, because you can also ask people to actually state more. You can ask them to write more things. So I often take the example of the color of a sheep. Like everybody knows they are white usually. So we just never say that, but you often see black sheep mentioned on the internet. So when you ask a model what color is a sheep, is like, I don't know, maybe black, because that's what people say more than white, right? So the models are lost by this, but we can kind of fight this by writing more, explaining more, like building data set ourselves. But then you need to have enough data. And then there are some limits to just the fact that you're not embodied in the world. Like we have this very intuitive notion of what is an object that is actually something you cannot, fully convert in text. And here there is a very deep limitation to how far you can go. And here it's not really clear how far we can go with text alone, and where we will be limited just by the fact that there is too many things in real world that we would need to encode to really transcript the real world into text only. Right?
It's very interesting, because language is the way that we, communicate as humans. But when we communicate, there's this sort of basic set of knowledge that we all just assume we have, and it enables very efficient communication, right? And I mean, it kind of makes sense that we would evolve to do that, right? Because we don't want to sit there and explain every little detail about every little thing in a scenario of life and death, right? We want to be quick in the wild. We want to communicate complex ideas rapidly. It then becomes complex for technology. I love the sample that you gave about the black sheep, because that makes so much sense. Like with BERT, for example, if you were to train the model to do like predicting a masked word, and if it's only ever going to see black in front of a sheep, then it's going to associate the two, of course. And so that's an interesting example to think about. Now we'll get back to sort of like common sense and reasoning in just a moment. But first of all, I actually want to take up a question from the audience that we got really quickly. This is a question from Tassin. He's saying that quite a few people joining the stream are new to the world of natural language processing. So could we briefly explain, what exactly natural language processing technology is, what it enables us to do, some examples of the technology in action?
Yeah, yeah, that's a good question. It's actually a very, very wide field, so I don't know everything, and I don't master every part of it. The idea is that you have a model that will have some inputs and outputs, basically. Well, that's the way I say that, but also bear in mind that I don't have a PhD in this field, so I'm mostly like self-taught. You have a model which has input and output, and at least one of the input or the output is text format. So it can be text to text. That's what I work mostly with. Like it can be text as input, text as output. So here examples are like of real life application are like translation. I think the most widely deployed model are like Google Translate or all the translation where you have as input text in one language, output text in another language. But you can also do summarization. So it's very useful as well. You have a long text, you want to extract a small text. You can do dialogue. If you have some history of a dialogue, you can generate the next tutorial. So there are many, many things you can do. And you can also just have the output can just be a class. That's another thing which is very often. So as input, you have, for instance, a text, and you want to classify it. Like you have tweets, and you want to say, oh, are these positive or negative tweets? Are they like, do they convey positive emotion, for instance, negative one? So this is one. And another example, a bit different, for instance, that you may have audio signal as input, and then you have the text as output. It's also very useful today, right? You have a text to speech to text or text to speech generation. So yeah, there are many things you can basically do. Pretty much every task or like everything we do as humans can actually be casted in kind of an NLP task, as long as there is some communication involved.
Yeah. Communication being powered by natural language is pretty incredible. And even just last night, actually, I was thinking about this, that this is actually a real thing that happened. Last night I went into bed and I was like, I got to wake up tomorrow morning for this episode. And I literally, all I did was I said, the wake word for Siri, and I don't want to say that, otherwise all my devices are going to go off with Siri right now. But, I said the wake word, and I was like, set an alarm for 7:45 a.m. and it did it, right? And the fact that there was so much technology involved there and it just all worked without me thinking about it is incredible, right? I can communicate with my devices now just like I would communicate with another person. Of course, not exactly like that, but we're getting there. The fact that I can take audio being sampled at thousands of data points a second and convert that to text, to characters, and then we can then use further natural language processing technology to understand the meaning behind those words in order to classify it to, oh, you want me to set an alarm, this is the time that you specified, and actually get that action done, and then actually synthesize a response, which is mostly scripted by Apple, but take that response and actually go ahead and sort of synthesize audio from it. All of this, I think, is really incredible that we can even do it. So there are lots of little components behind, like, for example, systems like Siri that are powered by natural language processing that add up to the sort of behavior that we see.
Yeah, maybe we'll talk about that later, but that's also one limit. It's an interesting limit, is that it's so fundamental for us. Communication is so deeply wired in our brain that it's also very hard for us to understand what this NLP language cannot do. Once they start to do something, it's a bit like kids. When they start to do something, you're like, oh, now you can understand everything. Let's go. But the reality is that no, they cannot. But it's harder than some form of other modality, I think, just because language is so important for us, so like just important to the fact that we can think, that when something starts to use language, we already think, oh yeah, let's go, you understand everything.
Yeah, kind of like, and we'll get to this in a moment. As actually, how about we actually get into that now, right? Like we've seen, as you mentioned, examples like OpenAI's entire series of GPT models, starting at GPT, which didn't really get that much attention. Then we got GPT-2, which got all this different attention and hype from a lot of folks, and then there was GPT-3, which got even more hype from a lot of folks as well. And my question for you there is, we've seen OpenAI scaling this model from a billion and something parameters to 175 billion, and yeah, of course, when you get a model that's 100 times bigger like that, you're gonna have better performance, right? But we're starting to see diminishing returns, in the sense that it's 100 times bigger, but not necessarily 100 times better, in a lot of the different use cases that we use it for. And scaling it up further, I'm not particularly sure if the mathematics behind this are going to let us continuously just get better at every task just because we're throwing more data and more compute in a larger version of the same network. So my question for you is, what does the future of language modeling look like in specific when it comes to things like GPT-3? Do you think we're just going to see much larger language models and more data, and we're going to see gradient descent eventually converge to things like common sense reasoning based off of that? Or are we going to have different architectures that enable us to actually have neural networks understand the world better? What do you think the future looks like in that sense?
Yeah, that's a good question. I think yeah, there are several ways to do that, to see that. I think what OpenAI is doing, and also Google, because they are kind of like the two, and maybe a little bit Facebook, they're like just a few teams working on this quest of just looking for the biggest model, the biggest possible model. I think it's interesting to see how far we can go, because we know there are limitations by this, just because you only like learn the words by co-occurrence. So you only have this statistical approach to language where you just know the relative kind of thing, but you have no absolute grounding. You just know the relative position of the words with regard to each other, if you want. So it's very interesting to see how far we can go. And I think GPT-3 is also interesting to show that we can do some stuff that we thought were like not possible, or at least we can make something that looks like it's doing this. And T5 was also very interesting data point, I think.
Yes.
And the G-shard model also of Google, there are many people doing that, and I kind of look forward to people training trillion parameters model. But also there is some limitation. We know that there are, and also I think there is also like more meta approach, which is that this kind of restrict the field of science and the field of people who can participate. So I personally am more interested in trying to push for like other approach. I think a lot of what these models do is actually memorizing the data set, like a lot of that. And I think in this regard, like there are some new models, kind of like Marge or Realm or KNNLM or like RAG or DTR, these kind of new models, which have this part of the model, which is actually the data set. They have a non-parametric part, which is growing and which is actually including the data set. And the nice thing is that you can make this a lot more efficient. This is one nice thing. And the other nice thing, because you have a sparse access, you don't need to process all the data set. You just query. It's kind of like a database, but the database is built by the model during the training.
Mm-hmm.
So one nice thing is that it's probably more efficient. And another nice thing is that the knowledge can evolve. I mean, it's kind of sad to see that GPT-3 costs so much to train, and it will be stuck with its training data set. It will kind of always think that the president of the United States was the president of the United States in 2019, and in 20 years from now, probably it won't be the case. So if we have a way to have continual learning, which is also very important for our models, I think that would be nice. So there is a couple of limits to this quest for bigger models, besides just the fact that you were saying, which is very true, which is that we have this requirement to exponentially increase the size of the model just to get a linear kind of increase in the metrics we are tracking. But yeah, another approach, which is also I think that's the underlying idea at OpenAI, is that there might be a phase transition in the behavior of this model behind some above some kind of threshold. Maybe the model which just qualitatively behave differently. That's the main idea, I think, behind their research program. Maybe if we reach big enough, then we have a phase transition, a bit like in physics, where the water freeze below some point, or like the water is changed into a gas, and that might be the same case. And then we phase transition to another kind of behavior, totally different. I don't know if GPT-3 has reached this yet. My opinion is that it hasn't, but I have not really been able to investigate the model that much. So.
Hmm. Another thing that sort of hinders the fact that we can't really investigate that much, I think, is that it's not open source this time, so it's a bit more difficult for researchers to really figure out more about what the model's doing, how it's working, what its performance is like on different tasks. But at least we might have API access in a little while. So that's definitely an interesting way of thinking about it. And I also sort of think that we haven't really reached that point yet, of where the water starts to freeze, and where we start to get really good models. But and what you mentioned around this making research inaccessible, I mean, I sort of love the work that Hugging Face has done actually with like Distillbert and DistillGPT, and making those so accessible through the Transformers library, because now even if you don't have data centers worth of TPUs and GPUs, you can still use and train these sorts of models on tasks to understand what the performance is like. And we'll get to the importance of why exactly Hugging Face believes that making, and why you believe that making these technologies more accessible is important. First, though, I want to talk a little bit more about what you mentioned around models memorizing data, because that's something that's actually really interesting to me, right? The fact that as we try and optimize the weights in this network, it realizes that memorizing a lot of the data is the best way to go about solving the problem, right? I'm sure you've heard of this. I'm not sure. Have you taken a look at the work that they've done with BERT and these thing called structural probes? Um,
Yeah, I did a little bit, but there are many works on that. So if
Yeah,
you're
I
referring
mean
to
the
one,
one that I'm referring to specifically is the one where they were able to figure out that within BERT, if you were to take the embeddings and if you were to map them a certain way, then you get a really really close to a representation of a syntax tree, like an actual
hmm,
syntax parse tree of language within BERT's embeddings. And what's interesting to me there is that BERT sort of converged to a set of weights where I'm gonna use words that are kind of humanizing BERT in a way, and I really don't like having to use these words, but it's a constraint of language, right?
yeah,
This is something that me and one of my mentors, Tim, have been talking about a little while, for
yeah.
some time. It's like we have to humanize these neural network models, but I'm gonna do it anyway, just for the sake of clarity. And what I mean
That's very
is,
good to be aware of that.
yeah. It's important to think about that. But like Bert realizes, for lack of a better word, that a good way to be able to predict masked words is to understand the structure of a sentence. So, for example, you know what it refers to in a sentence. You know what different parts of a sentence are related to each other. And so that sort of hints to me, at least, that these models are capable of definitely, memorizing data is a majority of what their weights end up learning, but they do end up learning a little bit of that, sort of the thinking that goes behind, what do I do with this memorized data? But we haven't seen that grow into anything particularly more than just syntactic, maybe some semantic understanding to logical understanding. Why do you think that hasn't happened, and what sort of work have you seen to sort of work towards solving that problem?
Oh yeah, that's a good question. Yeah, that's right. I mean, let me answer. Yeah, I won't give any definite answer, but
Yeah.
let me just shape a few directions about this. I think one first direction is that this field of studying these models is, I think, very interesting. It's called Bertology. It's these people who try to understand how these models works. And the work you've been mentioning definitely belong to this. There have been a lot of work. And right now in this field, people are kind of questioning also this first insight. They're like, okay, we've seen we can extract syntax tree, dependency tree from these models, but are actually the model using them?
Hmm.
And it's not so clear. Actually,
Interesting.
it might be just a side effect, and the model might just not have to use them, or just not using them. We need like a causal way to understand if this is the cause of some decision, and it's not really clear. So
Hmm.
there is some question. It's still very open, I think. But yeah, people have been seeing this thing. So this is the second thing, is that it's kind of like, this is the reason also, because before that you were talking about distillation, but this is also one of the reasons distillation is working. Basically, we think like one way to see that is that this model, they are very weak inductive bias, these transformers, and training them on large amount of data can build some bias in them, like build some generation capabilities in them. that we can then distill in smaller model. And that's why we can train smaller model with distillation, because these models, they have, and one way to put bias in your model is to kind of put it in the architecture, and another way is kind of like just to use the data to have this inductive bias. So here bias is this positive way. Inductive bias is a way to learn something faster because your model wants to go in the right direction. Your model has this inductive bias to go in the right direction. So this is the thing. Now on the logical aspect, I think maybe one reason we might have not seen that. So one reason might be just that there are not so many benchmarks for that, maybe less than a benchmark for like syntax. We've done a lot. There is like a huge history in NLP about syntax tree, parse tree, and like studying them and trying to understand them. So this is like a really big part of NLP. So people kind of want to have a lot of benchmark, a lot of way to evaluate this. And like logic is more blurry. One reason is also that natural language is not always logic. Like we, as you were saying, we have a lot of underlying context, which means that often when you take the literal meaning of what you're saying, it is actually not logical, but you don't really use this literal meaning, right? It's the discourse aspect that you imply all this context that the people use to actually extract the logical thing from what you've been saying. So often we can say actually the exact opposite of what we mean, and the interlocutor will say, oh yeah, but you mean the opposite. So it's kind of hard to actually really evaluate logic with natural language processing. There is a limit here to how we can evaluate that. And the last reason is that these models, they're also very good at just catching very simple heuristics. So we see that there is a lot of benchmark, which actually we discovered recently were mostly flawed because they were too easy heuristics. One example is that you try to predict if one sentence is a contradiction of another sentence. And like in your data sets, there is often the word not if it's in a contradiction. Or like if it's not a contradiction, you have always like what we call lexical overlap. Like there is a lot of common words between the two sentences. And then the model kind of, instead of understanding the meaning, the model will just say, oh, I see not, so it's probably a contradiction between two sentences. Or the model will be, oh, there's a lot of common words, so probably it's entailment. Like, so the models, they are very good at catching these easy heuristics where they stay on the surface form and they don't have to dive into the meaning. So it's actually hard to even probe them behind the surface form because they are so good at catching this thing. Yeah.
That is almost frustrating to think about, that we're working with machines that are inherently lazy, like they are mathematically lazy,
Exactly.
right? They want to find the simplest solution mathematically possible to a problem. That is literally what they are built to do. And in a way, it's not really surprising that they do that. But in a way, it's a problem that we need to solve, right? One of the things that you were talking about, actually, no, that not that you were talking about, but that generally there's a data set that I found a couple days ago that I think really highlights the problem really well. And I've shared that with you. It's the Common Gen data set, which gives you like a set of concepts and expects you to synthesize a sentence from them. So like, for example, if you were to pass it dog, frisbee, catch, throw, then humans would write sentences like a dog leaps to catch a thrown frisbee, which sounds perfectly normal. And then you go over to GPT-2 and it's saying a dog throws a frisbee at a football player, or dog catches a frisbee and throws it to a dog from T5. So these models still have a long way to go, right? They're just staying at that surface level. Reminds me of that one time, and this is an example that I've given a couple times. I was training a spam detection model, and in the data set, all of the spam occurrences were really short and all the non-spam ones were really long. So all the recurrent network was doing was waiting until a certain length, and after that it would switch it would flip a switch, and then after that length it would be like, okay, it's not spam anymore.
You're not the only one.
Yeah.
Like, it's really surprising how some datasets we've been using for years, and just only today people are like, but actually the model is just not doing at all what we thought it was doing.
That is annoying.
But I think it's good. But definitely right now, today, people kind of like the new data set, the one you were talking about, which is very interesting. I think Common Gen, basically everything which is going from outside of Yejin Choi lab or Yejin Choi team is very great, I think. And this data set now, they are kind of created adversarially against the current model. We try to like find where the current model is failing and try to push this thing, which is a kind of a paradigm change in the way we're doing data sets. But that's where we need to go, because if we take the easy road, I think the model just won't do what we want them to do. Yeah, these lazy students, if you don't force them to think, they just won't think at all.
I feel like, in a way, what we've sort of boiled down to is that, really these models are lazy, right? And our mathematical incentives, our loss functions that we build, are really biased towards, if you get a couple of the words in the sentence right, it's good enough for gradient descent. That's all it cares about, right? And so no reason to think about logic if you can get a good enough solution and a low enough loss value just by looking at words, without having to understand their meaning, right? Like, just as you mentioned, even if BERT does end up as a side effect, creating a structural representation of language, doesn't necessarily mean it's actually using it, which is interesting to think about. And then, in a way, if it means that our incentives as humans, if we aren't able to build those mathematical incentives well enough, then maybe we need more neural networks to do so. So that's where GANs come in, right? So generative adversarial networks, we've seen they're great for images, mostly great for images, and we've seen like this person does not exist.com, where we get exceptional faces that you can barely ever tell are generated by a network. But then we've got language, where GANs don't work. What are some of the reasons GANs don't work with language?
Yeah, that's it's exactly the direction we should go, I think. So I think GANs don't work mostly because basic GANs don't work because the discreteness of language, just because it's discrete, and then also because there is so much information in each of these data points. That this is actually the 2 points we started with, right? This discreteness and the amount of information in the language. So I think these are like fundamental limits. But there is GAN-like setup, which are very interesting. And here I will talk about a little bit about Electra. I don't know if you know Electra, which is a very efficient way to train BERT. It was developed by Kevin Clark at Google. He's a PhD at Stanford. He's a great, very impressive thing that he has done. And the way they do is that, in BERT, you kind of mask these random words, and the model is trained to predict them. That's what you do. That's what you did in your first slides to show how you can mask these characters. And Electra, you have a second little model, which is a lot smaller, and this one will select which words to mask. We'll actually not mask all the words, because some words are very easy to train. And that was one of the first failure of the failure, not failure, but like non-optimal way to train BERT in the first paper, was that they were just masking random words. And sometimes it's very easy just because the word is like an article or just a part. They were masking subwords. So for instance,
a word piece,
prefix, a word piece can be easy to guess. But if you have another model which is in charge with finding the tricky one to mask, that's a lot more interesting. And actually the model learns faster just because it has more signal, like the signal is more valuable. And the fact that what you were saying is very true. I think the fact that we still train this huge language model like GPT-3 just with cross-entropy, I think that's kind of boring, and there should be better way to train. We should not have to like say for every word, this the article. It's still very important to learn it after like 20 epochs on 10 gigabytes. The models know it. You should probably put more signal on the important words, or like different way. So there is some teams working on that, like the Jason Weston team in FAIR is doing an interesting thing, like also, for instance, masking the previous words, or like so the models learns to not repeat itself too much, or like putting human in the loop where the human put a different signal. But basically any kind of more smarter training signal should be good to come. And GANs are one way. So we cannot do, in this Electra, we cannot backpropagate because there is this discreteness and this kind of sampling thing between the two models. But the idea is still the same. We have another network trying to like challenge a little bit more the language model.
Yeah.
And I think that's a very interesting direction. And what I like is that it's a lot more efficient.
Yes.
It's very nice as well.
Yeah, absolutely. I hadn't remembered the name, but I took a look at the technique, and it's something that I'd taken a look at a little while ago. And what's interesting to me about this is just how, what you mentioned is that we can get the training to be so much more efficient than just masking out random words, right? Like if you take a look at T5, they were training it to do closed book question answering. So they would train it to answer questions without being given any context. So you would ask it, who wrote Ender's Game or whatever, and you wouldn't give it a paragraph to extract the answer from. You would just say, whatever's in your weights, figure it out, right? I mean, as you mentioned, these language models memorize a lot of data. And when they did pre-training on T5, where instead of just masking out random word pieces, they would mask out actual, like entities within the actual sentences, then obviously they got way better performance because the model was now memorizing or looking at different parts of the sentences because now it was incentivized to look at different parts. So pre-training definitely has, a huge effect on whatever tasks you're going to be training on downstream. And it's definitely interesting to see how we're getting this training to be more efficient. If we can't design better mathematical objectives, let's have another neural network be that objective. Another thing that kind of seems a little inelegant to me almost, and something that I wanted to see if there's sort of research going on in this area is even just the way we sample from language models, right? Like the way we seem to be sampling from language models today, like top P, top K, beam search, they don't seem, it's fundamentally a different way of sampling than the neural networks were trained on, right? They were trained to do things greedily. And now when we sample, we're doing things probabilistically, like we're looking at the probabilities that the network outputs. That doesn't seem like a very one-to-one mapping to me, and I can understand why outputs from the network wouldn't make much sense in that case, because then the network was fundamentally not trained on what we're trying to do during inference time. So what are some of the new advancements in that area in terms of actually getting output from a trained language model in the first place?
Oh yeah, that's actually a huge area of research. Like a lot of people have been studying that. In RNN, it started with all the question of the exposure bias, which is what you're saying, that during training, the model just is trained to predict the next word. But when you unroll it in the wild, it has to use its own previous prediction to predict the next word. So it kind of leave the training, it kind of leave the training data set it kind of go out of domain sometimes because it selected a weird word and now it has to handle this and it never seen this weird word.
The errors stack up
in the training data. So yeah, there is this question of exposure bias. What we've seen is that there are some ways to handle that, like beam search for a long time was one way also to help the model. So you keep a beam, and if the models kind of go in direction which is too weird, you just keep the other beams. Right now, we also see that if you train this really big, larger model like GPT, they are better calibrated. So they are better at handling this long-term self-generation. But there is still limits. If you test GPT-2, it's kind of, for instance, sometimes it repeats itself. But in the training data set, you never see repetition. So how come that happened? So a lot of people have been working on that. One option that people use right now is sampling. There is a nice work by Harry Holtzman, but there are many people working on that. But Harry Holtzman had this nice work about nuclear sampling. One idea behind sampling, well, first thing that if you compare statistical generation by a model using beam search versus sampling, if you compare both of them with the way humans do, like the statistical text of human, sampling is a lot closer to how we do. The statistical aspect of generated text using sampling is a lot closer than beam search or greedy decoding. So probably it should go this way, but sampling also is a bit weird, right? Because that means you take a random word at each step. And we don't think we humans really do that. We think we have a direction where we want to go, and we kind of follow some direction. We're not randomly sampling something. So we would actually to say, to have, for instance, a few anchor points or one idea to say, oh, the model should say something like this, and then the model decodes something that go like this. But this is very hard. And also it's very hard to train the model to do that, because if you want to unroll the model during the training, then your training computation kind of explode. So yeah, I agree with you. And I think a lot of people agree with you. This is not satisfying, and we should be able to do other way. So some people also at NYU, for instance, Kim Young Cho has been doing non-autoregressive generation. This is also a funny one. So you try not to generate word by word, but you try to generate one sentence at a time, like a full sentence. So usually the first sentence is pretty bad. So you kind of use it as a initial starting point to improve it. So you kind of do a few iterations. And there was also some word from Salesforce on this. Like this is called non-autoregressive decoding. But right now the quality is not as good as autoregressive decoding. So right now it's better just to go one word after the other, even though it's definitely not convincing for humans. We're like, no, this should not be done like this.
Yeah.
Yeah,
I
it
saw a
helps.
paper a little while ago, and I didn't see much research come out of it, but there was one paper, and it's something that really fascinated me, and I thought was actually a pretty interesting way of doing things, and if I don't think I can pull up the paper right now. I've pretty much lost that as of now, but I'll be looking for it for sure.
Yeah.
And essentially, the idea behind it, and this was back when Transformers weren't as popular. This is and maybe you've seen this, where they would, instead of like trying to auto-regressively generate the whole sentence, they would auto-regressively generate all the nouns and then all the verbs, and then they would sort of insert the verbs into the auto-regressively generated nouns, and then they would insert the adjectives, and then they would insert, sort of in a hierarchy. They'd have four different levels of decoders where they would auto-regressively add information. Do you think that's intuitively? Do you think that makes sense for increasing the sort of
Yeah.
sensibility of these sequences?
Yeah. I think, well, I've seen this, hierarchical kind of decoding approach. Some people have been doing that also in dialogue, like decoding first, like a one hidden aspect. Well, usually one limit you see is that encoding one thought, or like what we would say one meaning, is often not like equivalent to one word. Like a meaning is usually like a periphrase, or like the blue dog was running. You cannot just say, oh, what is the most important word here?
Yeah.
Is it dog? Is it running? It's like a full thought they had to put down in just one word. So yeah, that's sometimes the limit of this model. So you can try to just encode this as a hidden vector space, and then you decode from this, saying, okay, this is the hidden vector space, the hidden vector that kind of should encode the thought. That's often what people do when they have a multi-scale decoding thing. But yeah, there was also some works on templates. There have been some nice work by Sam Weisman, for instance. Like you have some generic templates that you can generate, which is like this generic kind of probabilistic formulation, and then you fill in the templates. But yeah, all of this hasn't really be, none of this has really become mainstream. So yeah.
Well, we can wait for the day that eventually we get more elegant language models to use. But yeah, that's really interesting. Now, I do want to sort of also really quickly before we move on, one thing I do want to mention is that we are getting lots of questions from the live stream, and we will be covering them. So if you have any more, feel free to send them in. We will be covering them in just a moment. I see quite a few from Tim and Venkat and Tassin, and so we will be covering them momentarily. First, though, I want to sort of change what we've been talking about. We've been talking about the sort of more technical angle of NLP, and maybe we'll come back to that in a moment. But now I want to ask you more about what NLP and specifically things like being able to generate really realistic language, what that means for us as humans. There's been I personally believe there's been a lot of fear around language models that isn't necessarily justif- at least completely justified, in the sense that we're more scared of it than we should be. And I wanted to get your thoughts on what some of the sort of maybe ethical concerns are of just taking large language models like GPT-2 or 3 and just releasing them into the wild and allowing people to use them. Um, what do you think some of the issues could be? What do you think some of the how do you think we can work around those issues? What do you think about that?
Yeah, that's a good question. I think it's important for us because like Hugging Face is a very mission-driven venture. Like we really think it's important to do this right. On the other hand, I think like a lot of people have been talking about like fake news generation or things like that, but I think like that it's more a channel problem. Like today, I think it's already very easy to generate fake news in large quantity just because you can pay people to write stuff in English at a very low price in some countries. So it's actually very easy to generate, and probably I've seen actually a lot of places where when you try to do like cheap work with a neural network, it's actually more expensive than just paying somebody in a country where the salaries are a lot lower. So it's actually very hard for a language model to compete with that, just because the computation is too expensive, and also because it's actually very cheap right now to generate this kind of text. So I think the main problem is more channels. Like, we should have more filtering on how you can like inject this fake news in like social media. We should have more like, well, that's my personal opinion. We should have more like a way to say, okay, if you're not identified, if you're not like a trusted thing, you should not be able to inject like a fake news or something like that. But yeah, so I'm not really scared about a huge wave of fake news. We already have them pretty much everywhere. So I'm not really scared it will fundamentally change the thing. But I think there is very strong ethical question, which are more when we try to start to use these models to make decision. Like, so it's not really generation, but we use a lot of model for data analysis and extracting information and then taking decision, like NLU, we call that for natural language processing. It's more like understanding, natural language understanding. So for instance, if you start to grade student essay using a language model, I think a lot of people who want to do that just don't understand what are the limitations of this model and how they can be really biased very strongly just because of the way they were trained or because the data set they were used to be trained. But then we kind of put this model in the wild. People use them to like take decisions, say, okay, no, your essay was not good, or like your loan, like the bank just don't want to give you money because, I don't know, just the AI said that, and it kind of looked like it's fair, but it's not fair because the AI is trained on biased data. And we know that like very clearly right now that all these large-scale language models, they are very strongly biased against minority. They usually have bad gender bias, like they think like all the women should be nurses, or like all the men are like mostly lawyers, or like they have this very strong bias that we can see. And the people just don't really, the people who use this model don't really know that, or just don't want to know, and they kind of hide this decision behind this fairness of algorithm, and this is very bad, I think. So yeah, this is the most, for me, it's most important in the short term. This has a strong effect on people's lives. These are what we call social outcome. Like there is like people life which are changed because of this in a bad way. So this is where we should be focusing more, I think, instead of the AGI hype of having like a kind of a lot of fake news everywhere. Yeah, so that's what we would like to push for us, which is ethics and bias. I think the most problem, the strongest problem in the field right now.
Yeah, I really, really agree with what you just said. And for the longest time, as I've done all sorts of different keynotes and different like workshops and talks at different conferences, literally one of the main messages that I've had is that there's a lot of hype around these technologies, around like, especially what you mentioned around like AGI, for example, right? There was one really famous blog post about GPT-3 being like, hey, is GPT-3 an example of one of the first AGIs that we've built, right? And I quite strongly disagree with that interpretation of these different language models. And again, I actually love the way that you put it, really, because language is so deeply ingrained in the way that we think as humans, in the way that we represent our thoughts even in our own heads. When we see a language model start to generate language that hits different than seeing it generate a face or generate something else of like that, right? I could train a generative adversarial network to generate 3 points of data in the iris data set, or I could train a generative adversarial network to do a face. They're fundamentally the same thing, but you're gonna perceive it as a human, two completely different pieces of tech, right? Even though they're fundamentally the exact same math. Well, not nearly the exact, fuzzily the same math. And I mean, the bias, I think, is really definitely one of the main issues that we need to work around. I mean, I actually really appreciate. A little while ago, I was going through the Hugging Face website, and I was actually searching up the Roberta Large model, and I scrolled down, and there's actually a section that I saw called Limitations and Bias, and I really like how you're just really driving attention to the fact that it is biased, right? So like, for example, you feed in to the model, the man worked as a, and then you mask out the last word and it predicts mechanic, driver, or teacher. and then you ask, or you feed in, the woman worked as a, and then it predicts nurse, waitress, or teacher. And so,
Yeah.
there's definitely bias here, and that's something that we need to solve. As a matter of fact, technically it's not the models that are biased, right? I feel like that's also something that a lot of people that aren't that deep into the tech sort of misunderstand. It's not like the programmers behind these models are going, this is what we want to do, this is what we want, this is what we want the model to output, right? But rather it's just the data is inherently biased. If you're going to scrape outbound links from Reddit of all websites especially, then yeah, you can expect that the results are going to be biased. So what work have you seen to
Yeah.
sort of work towards solving this problem?
I think so first, yeah, I think we're not doing enough and we want to do more. I think that's the first thing, because you were saying we do some stuff. I think we do, but not enough. I think we want to do. And one way also we want to do that is with the community. We've always been doing that as a community project. And I think we want to have the community involved in this as well. This is very important. This is also maybe why it's going a bit slower than if you were just doing this on our side. But yeah, this model, they can also amplify bias. It's not always very clear for people, but there was this funny thing that happened at Amazon, I think maybe last year, where they tried to swap their hiring process with a algorithm, and basically they just train it on the past data, and they were just recruiting less female than men. And the model just learned that if you are female, well, you should have a lower score just because you have the wrong gender. Well, that was the model idea of it. And then the model kind of increase that, because they kind of take that as an important thing. And this is the main problem. You can start with a data set which is slightly biased, and the model will actually kind of force this thing bigger. And this, we don't really understand exactly how it come and in which circumstance. Also because bias is very, as you were saying, it's kind of hard to also clearly define. There is some part of what we would call bias is maybe just common sense. There is just some stuff that are like common sense, and there is some of this common sense which is common sense we don't want to keep, which is just the common sense of your racist grandfather that you don't really want to keep in the real world today. You would like to change this and say, yeah, actually today women can vote, so maybe we can change this common sense view of this thing. So it's kind of hard to tell, and obviously it's all very blurry. So it's a difficult topic, but I think it's a very important topic.
I completely agree, right? There's so many biases that I believe that we don't even realize we have half the time, right?
Yeah.
And when we take this sort of technology and when we make it accessible to more people, right, I feel like that also in a way helps work towards solving this problem, because when we're giving these models to more people, when more people have access, like for example the cloud, right, it's really democratized compute power. The Transformers library has democratized access to the software, and by doing this we have all these different people working on these different models with their own priorities, with their own wants, their own needs, working towards building a more fair world of machine learning technology. And you're right, we're not doing nearly enough work as we should be towards making this list less biased. I mean, if we were training like what you mentioned around for example, determining if you should get a bank loan, if we're training a pretty simple like feed forward neural network, then it's pretty simple to say, all right, we don't even want to feed the gender in as a feature, right? So fundamentally we're not classifying that or using that to make a prediction. But then when we come to language models, it's hard to say, I don't want to feed in the gen. That's not how it works, right? We're feeding in raw language,
Yeah.
right? So
even if in a simple case, we can see that this model, they kind of found these confounding factors very easily. Even if you don't say tiring, you don't specify the gender, but they are like way to reconstruct the gender.
Yes.
The model are lazy, and they will be, oh, I saw a very easy way to predict the results. It's just to like see if you have babies, and if you like took some, I don't know, time off from your work at the same time that you get your babies or something. Oh, but you're probably a woman, and I know that this means no. So this is easy. They're very lazy, so they can find this stuff. But in natural language processing, it's even harder, right? Definitely, because there are so many ways to express these ideas. So one of our ideas, just to finish on this maybe, is that indeed just making this more accessible, just democratizing, just making this very easy to inspect, very easy to access for the people is one way to like try to fight this thing. Just because people can use this model very easily, just because they can play with them, then people will see more the bias, and that's one aspect of democratization in our mind, is just have people experience this bias, and just to try to have the maximum number of people play with them, maximum number of people raise issue about this model is one way to go forward, I think.
Absolutely. And again, as I mentioned, that's why I appreciate all the work that Hugging Face is doing, because like a lot of the work that I do with natural language processing, for example, is being powered by the fact that large models like GPT-2 are just readily available and accessible to me, right? And this is, I think, pretty incredible. It's really driving innovation. As a matter of fact, I actually wanted to ask you, what exactly about this sort of democratization of software in your case, do you believe that is so important? Like, why is that something that Hugging Face and you as a researcher focus on so much?
Um, yeah, that's a good question. I mean, for me, it's a very long quest because when I was doing quantum physics, it was very hard to get access to a lot of things, like a lot of paper publication were behind paywall or even like not accessible because they were before the internet. I was using a lot of Soviet Soviet research paper that were very difficult to find
Yeah.
on superconducting material. So I get this, and when I joined the AI field, I was like, wow, this is really cool. Everything is shared.
Yeah.
It's very easy to access. Like Arxiv, meaning you can read pretty much any research without paying. And I was really impressed by that. But then I saw like all this DeepMind paper I was reading. Actually, there was no source code, and you could not really like for a long time now they are doing it better, I think, but in the beginning you just had no source code. I remember the first Atari thing and I was like, I really want to play with this thing, but no, you could not access this. So that was very strong limitation that got me very frustrated when I joined the AI field. I was like, I want to play and to like experiments with the thing, to understand their limitation, to understand how you should change them. And so that's kind of how it started. When we started to develop our internal tools at TechLifeSkills, I was like, let's share these things so people can also play with them. So the first thing we shared that has some effect was the reference resolution thing you were talking about. And then GPT-1, when it came out, it was like, oh, this is really cool. We played with this in dialogue setting. It was probably the first time there was this large-scale transfer learning approach to dialogue generation. And then we open sourced this thing. That was the beginning of this. And then we saw the community was really interested in that. So like, this is actually the way we should go. And it's better for everyone. So for researcher, it's better also. It was the beginning of the study of bird as an object, the beginning of birdology. And I was a little bit scared that people would kind of overfit on this single pre-trained model and will be, oh, I see all these artifacts, but some artifacts are maybe just there because the model has 12 layers or because it was trying to drop out of 0.1. So it's like, okay, we need to fight this, and we need to make a lot of models accessible in the same API so people don't really overfit and they cannot play with all these models. And they're going to make better science just because they can compare them together and see what are the commonality between all these transformer models. So that was also one idea of democratization, which is just, let the researcher use this model very easily so they can have a good baseline, they can make good science, and also gather a lot of them to inside, so they can like extract the maximum amount of scientific information from all this population. And I'm very happy that the field of biotology and the understanding of this model is growing right now. I think we're discovering a lot of interesting things. Also about language itself, we're understanding like translation, we're understanding a lot of things that we did not really understand.
So much better science is possible when technology is accessible to more people. I completely agree, and that's definitely important, I think, especially when we're seeing such complex technology. Being able to make it more accessible to people so that everybody can work towards finding new things, I think is really important. I mean, imagine if Google had kept BERT, a proprietary little trade secret for better Google search, right? We wouldn't have any of the modern transformer innovations that we do today, right? And I think that's really important. Like, Apple used to not have much machine learning talent until they finally opened up their Apple Machine Learning Journal, where they started to publish some machine learning stuff, and suddenly people wanted to work at Apple because now they can actually share the work that they do, right, with the rest of the community. So I think that's definitely really important. And now, actually, we've been discussing quite a bit. I mean, thank you for sharing so many amazing thoughts. And now I want to transition over to some questions from the audience. We're getting quite a few. I'm going to start off with a question from Tim Duncan, actually, and this is very interesting. He's asking, have you ever done any work on generating an image from a set of concepts? So instead of generating a sentence, you actually generate an image, and then to extend that question is you could then decode that image into natural language, or you could feed it through an image classifier or whatever.
Yeah, so I haven't done that, but there was some interesting work. I remember I could find the paper. That's a little bit maybe 1 or 2 year old now. On like having some kind of GAN setup in caption and image generation. So you generate an image, you can try to extract a caption of it, and then you can try to generate the image from the caption as well. So you can have some interesting interaction where you train a pair of neural network. I think that's interesting. The field of multimodality is, I think, just starting to grow because people are like seeing the limits of text and try to find some other way. And also we have more compute, so because obviously it requires more compute. But yeah, I can see this becoming very important field in the future. There is probably some limits. I was talking about that with Daovi some time ago. Some limits to the fact that images are fixed. They are like static things. So this won't be the perfect complement to text. This won't teach us like how the world is moving, how the world is dynamically updating. So maybe text and image is not enough, but that's one way in the right direction, I think. Yeah.
Interesting. And then there's some sources of data that are fundamentally temporal, right? So natural language is kind of temporal, kind of discrete. Like it's weird the way natural language is, right? We treat it as a time sequence, but is it really a time sequence? And at the same time, we treat it as discrete, but is it really discrete, right? It's sort of a weird in between. Then you've got images that are just totally discrete, and then you've got audio, which is totally, definitely temporal. Fundamentally, audio is movement, right? Movement of vibrations of air, right? And so that's seeing where these data sources connect, I think, is going to be the next frontier of innovation in a lot of these fields. Tim is saying I would love to read that article, so if we can find a link to that paper, we'll definitely put that in the comments. Another interesting question before we go to more technical questions, just a sort of fun question to start off with, from Tassin. He's asking, what were some of the most interesting moments that you've sort of had working at Hugging Face?
Oh, I mean, working at Hugging Face, honestly, it has been just really a wild ride. I was before that I was a lawyer, so this is very different profession, right? It's kind of like it's moving from this to Hugging Face is a huge change. So yeah, everything has been a wild ride. Just the beginning, then getting some good results on like this Europe's competition was a thing that was with GPT-1. The first time we kind of won a competition, and then open sourcing BERT and just like kind of moving to this open source thing and just finding that this was actually so much more interesting than I would have thought. I mean, we kind of discovered the open source with our big repo. We were like, okay, what's this? I was in the beginning, I was like, how do you push something on GitHub? What should you do? And now it's like this crazy huge monster, which is sometimes a bit too big for me as well. So I've started smaller libraries, which I think is kind of nice as well. And then recruiting the team. The team is at Hugging Face is really amazing. And I have this weird thing. Like last week, I had to like explain to one of the guy that he was working too much and he works less. And he's like, it's important that he find a good work-life balance. And sometimes the mission is, I think, a bit too big. Like people who join, they are really, really happy and they have a lot of freedom. So they work on what they want. And it's, so yeah, I'm still discovering a lot of things, like just how you can get people to give the best of what they want, to be the happiest in the team. And yeah, this is also a part I like a lot, I think. And building tools, yeah, just enabling research. That's probably, yeah, maybe the most rewarding is when some like researcher stopped me at a conference and say, oh, I've been using your tool for my paper like this, and we look at the paper together. I'm like, oh, this is really great, and I'm super happy I was able to do that. Yeah, this is, I think, the most rewarding part.
I can imagine that would be really satisfying, knowing that so many different pieces of research and papers are being powered by the library that you and your team have built. And you're right, it's that passion that the team has that really makes it so you have such amazing tools and code and repositories even available, right? It's because your teams are so incredibly passionate about the work that they do. So it's wonderful to hear. Actually, before we continue with audience questions, another question that I have really quickly. This is more on sort of like the computer science end of machine learning. I've personally always thought that languages like Python are kind of limiting in the way of what they let us do with machine learning, right? Like the tokenizer is part of Hugging Face, right? That used to, of
Yeah.
transformers, sorry, that used to be in Python, but now it's rewritten in Rust, and there's bindings for Python, so it's faster. And this introduces the sort of problem of there's so many different languages, right? We've got to have Rust for the tokenizer, and then you've got to have the binding into Python, which is fine, and the transformers library makes it work very well. But inside, there's so much plumbing going on of just getting different parts to connect with each other. So there have been a couple solutions to this problem. One of them is the Julia language. One of them is the Swift for TensorFlow sort of toolkit. What are your thoughts there? Do you think that these languages, not necessarily in the near future, even in the far future, do you think they're going to slowly phase out more compartmentalized approaches, like having parts in Python and Rust and C and everything, versus just having, a majority at least Swift code base for your machine learning code?
Yeah, that's a very good question. Yeah, I think, for instance, Julia is really, really interesting. Swift as well, yeah, for different reasons, I think. But yeah, it's hard to say. I think the paradigm of Python, which is like you have this very simple to tweak scripting language, and below it, like under it, there is this very fast thing that you call. I think it's quite powerful in the end, but it requires a lot of plumbing, as you say. Yeah, it means you need to connect this thing, and it's a lot of work um, to build this, and also to maintain it later, to make it work, where like both language evolve and things like that.
Mm-hmm.
Yeah, I think today Python yeah, it's hard to imagine Python really being replaced by something else, even though
Yeah.
it's not the best language. Clearly, there could be better alternative. Yeah. So yeah, I think we kind of be stuck with that for a long time, unfortunately. And because actually, yeah, a scripting language is nice in some way, I think. Yeah. I haven't played enough with Julia. This is one of the things I would like to spend more time on when I have some time. Rust is a choice because some of people in our team like a lot Rust. I think it's very interesting in one way because it's the exact opposite of Python in some way.
Yes.
It's very safe. It's very like clean. Like you have this compiler that checks that everything is going to run well.
Yeah.
It's the exact opposite. So when you put the two together, kind of makes some sense, like the
Yeah.
complementary things.
Yeah.
So it works well with Python, but basically I wouldn't like to code a full library in Rust
Yeah.
just because there is too much. So probably I would go more if you had to choose one language. Yeah, Swift and Julia are kind of thing that comes to mind. I hope Swift will keep some stream, and we'll keep some adoption. And Julia already has a kind of a critical mass, I think, to keep growing. So maybe in
Yeah.
a few years, yeah.
I agree, and we'll be finding out more about that next week. But I don't want to give away too much, so just stay tuned for that. But yeah, Swift and Julia are both projects that I'm very very passionate about. As a matter of fact, those are the two languages that I've actually written books on. Right, so there's my book about Julia over here. There's the one about Julia that I wrote with McGraw-Hill under the Tanmay Teaches series, and then there's also my book about Swift that I'll go get in a minute. But as you mentioned, it's hard to envision something replacing Python just because there's already so much code written in Python, right? And it's so easy for a beginner to just say, all right, we can just get started with Python because it lets us do duck typing, and we can do whatever we want, and Python doesn't care. And then we've got, as you mentioned, the exact opposite, which is Rust, making sure we know when memory is, allocated and deallocated at compile time without having to manually do that, ownership and all these things. And then we got sort of things in between where Julia's more towards the Python side, where it lets you do more like scripting, but then it has a garbage collector, so it's not, fully deterministic that way. And then we've got Swift, which is sort of more towards the Rust side of the spectrum, but not as polar as Rust is, right? So I think it's an interesting spectrum. We got Python, Rust on one end, Julia, and then Swift, and there's so much stuff in between. And what's interesting is you move away from Python and you start to notice a lot of the things on the other end, from Julia to Swift to even Rust, all of them powered by LLVM. So it's anyway, compiler technology is really interesting to me, but that's not the point of today's episode. That is next week. But yeah, now I want to go ahead and move to a question from Venkat from the live stream. He's asking, what deep learning techniques does someone need to know to be good at natural language processing? So he doesn't want to learn everything under the sun when it comes to deep learning. He's asking what parts of deep learning are important for natural language processing.
Oh, okay. Yeah, so that's pretty easy if you only want to know just one part. But then, yeah, I mean, I think it's good to know a little bit more than what you need to use. That's my personal view of everything. So I think if you want, you should continue after that to learn more things. But probably you want to learn about transformers right now because they are so big in the field. You want to know a little bit about LSTM. I think I don't really teach them anymore because yeah, they're not using any transfer learning approach, sadly. I'm not against LSTM. I think they were nice. They were quite complex, I think, to teach. So it's actually a lot easier to explain to somebody how a transformer works than an LSTM, in my opinion. So for transformer, you need to know what is a word embedding. You need to know a little bit about word2vec. That's the simplest approach to word embeddings. You need to know how you do a linear layer projection. So this is very easy. An attention layer. So this you can. I don't know if it's in classes here. Yeah, but and then you need to know how to train a model with cross entropy. I think a good class is that's the one I follow in the beginning, which is the class of Chris Manning and Richard Socher at Stanford, CS224D, something like that. That's a good class, and they cover transformers, and you have all the video online. I think that's probably the best introduction to NLP right now. But yeah, I haven't been following. Maybe there are better classes, but this one is a serious one. You can trust it.
Very nice. That's interesting to hear. And, I totally agree. I think honestly better to know a little bit more around what it is that you're doing, because then, again, we don't give ourselves as humans enough credit. We are really good at transfer learning. We are really good at taking concepts from one area and transforming them to another. I mean, you come from physics background, and we were talking about GPT-3, and you're like, oh, maybe we reach that point where water turns to ice, and maybe we reach that point where after a certain point the models suddenly become really good. So there's just those connections that we end up making that we don't really realize a lot of the time. We don't give ourselves credit for. And you're right. We've seen this sort of transition to deep learning models that I think are a bit more elegant. We're starting to sort of getting there. LSTMs were kind of large and really big ship for something that maybe doesn't need to be that complex to sort of solve problems from RNNs, right? Like there's this one YouTube tutorial that I have about the unsupervised sentiment neuron from OpenAI, which is a really fun example. And the first hour of the video is just me on a whiteboard literally diving into an LSTM cell and what the operations are and how it works and why it works. And
some time to explain, huh?
Yeah, exactly. Yeah. But then with transformers, it's actually quite a bit easier. We can actually dive into the internals without having to understand all the intuition behind the complex operations going on behind it. So, and of course, we don't need to do the whole back propagation through time nonsense. So, yeah. That's that was annoying. But yeah, at least we're getting there. So yeah, that's hopefully that answered your question, Venkat. If you have any more questions, feel free to put them in the live chat. Another great way to get started with deep learning, if you want to learn about different sort of libraries like PyTorch, how they work, what gradient descent is, that sort of stuff. There's a course, it's called the PyTorch for Beginners on cognitiveclass.ai, so that's something else you can take a look at. Another question from Shiva. What does the future of natural language processing look like 10 years from now, in your opinion?
10 years from now?
Yes.
Okay. I'll be a grandfather by that time. Yeah, it's really hard to say. I don't know. 10 years from now. I hope it will be very different. That would be more exciting than if it's still like GPT-10 or GPT-13. But yeah, I think if you compare just 2 years ago to right now, it has changed so much. Yeah, I think transfer learning and the general idea like looking at bigger data sets, just not focusing. NLP for a long time was focusing on just, we have this small like small task data set, let's try to train the best model on this data set. I think this is gone for now. For now, like this is finished. Now transfer learning is very likely here to stay. Sparsity is a strong thing, so I would be surprised that we don't have very sparse model in the future. Hopefully people, like a lot of academia research team will still be able to train models that are close to the state of the art, or like hopefully this won't be just a big company fight, and hopefully still thing will still be open source and shared widely, and like everybody will be able to participate and understand what's going on and to play with the models. So these are, I think, the most important things. And then I think it will very likely won't be about text only anymore. There will be like either database or like images or video or human in the loop, but there will be another modality just to complete text. I think it's very likely that in 10 years we won't be training just on text alone.
Yeah.
And maybe RL will have Postgres for text. I don't know. This is still it's hard to predict. Yeah, but hopefully it will be very different.
Yeah, hopefully it is. You're right, because I really do not like the way we sample from language models today. But, yeah, hopefully it's very different in the future. So another question from Tassin this time. Tassin's asking, how is Hugging Face doing in COVID times, and how do you think? Okay, so we'll get to the second question in a moment. But how's Hugging Face doing? How's Hugging Face evolved in COVID?
Yeah, so it hasn't changed a lot for us because we were already a very remote company. I'm currently I live in the Netherlands. I live next to Amsterdam, but I'm the only one here. Well, we might have other people in the future, but right now I'm the only one. And we have a small team in Paris. We are very small, actually. We're just 20 people, 22 now, I think. We have 10 people in Paris, 10 people in New York. I think the main difference for us is that some people in New York were like, oh, maybe I should go to France. The situation look a bit safer. So we have a small movement from New York to Paris. I always have one intern in China, which is very, very good, and one intern in Berkeley. So from the beginning, we were a very remote company. Like all the founders, they've always been in like separate city. So it didn't change much. Yeah, surprisingly. Like the people in Paris could not go to the office anymore, so they kind of went to their parents' place or like to their own place, like around. But yeah, it's a bit hard sometimes when you're that much not impacted to really understand the life of people who are strongly impacted.
Yeah.
So yeah, it's important also to see. But yeah, no, for us didn't change anything pretty much, I would say.
But it is interesting to see. It's nice to see that Hugging Face continues to do the work, and hopefully things get better for everybody soon as well. Now another question from Tassin, actually, the second part of this question. So first, I guess I'm going to add a little bit to it. So what kind of work is Hugging Face up to now, and how is it going to be evolving in the future?
Okay. So what we do? Well, we are very open, I think. So if you follow a little bit us on the social media, you probably see like 90% of what we do. We share a lot what we do. So we do a mix of science and open source. A lot of we try to build tools for people. The science team is working on kind of the challenge we were talking, like more like trying to get more efficient model. We've been a lot of work on that. Victor has done a lot of work on that. Trying to do some zero-shot thing, like trying to do more robust model, trying to incorporate common sense. We have like a PhD starting on that very soon. I'm very excited about that.
Very nice.
So the science team is like tackling a lot of projects, mostly kind of general, like kind of higher level. We don't really focus on one very specific task in NLP, but more trying to tackle projects that have an impact across the board in NLP. Because we are small, so we try to find the most impactful product. And it's the same in open source. We kind of try to find the projects in open source which have the highest impact, which can have the impact in the greatest number of field in NLP, because it's more worth the time to spend on it. So yeah, I think we'll keep this mix of science and open source. It's working quite well, and they both kind of fuel each other. We do science with the idea to open source the code, and we do open source, which is very close to recent science paper and code. So we will keep these two aspects very close together. And what was the other part? How it will evolve? I don't remember.
Yeah. So how's Hugging Face's work gonna evolve?
Yeah, I think we'll keep something like that. We try to find also, we would like to find some business model that would be sustainable, that would keep all these values. So we kind of experimenting a little bit with things. For instance, when some technical things are more interesting for companies, like you want a very fast model or like you want some stuff like that, we might try to play a little bit with that. We probably will try to play a little bit with that. Some monetization around it, keeping this open core as a DNA and central part of a company. A bit like GitHub or this kind of open source company that are very synonymous with open access. So yeah, that's pretty much. So we have a strong focus on the dataset right now. I want to push this because we've been talking a lot about models, and we also talk a lot about how our models kind of inherit the bad aspects of our datasets. So I think there's a lot of things we could improve here, and we could help the scientific community focus on, or like make it easier for them to like evaluate this. So right now we do this kind of, well, I personally and like a few people in the team that work with me right now do a strong focus on dataset, trying to make them more easy to access, to make them more easy to inspect, to make it more easy to understand what are the bias in this specific data set and this specific data set. So these are direction we want to play with.
Interesting. Wonderful. Thank you very much for sharing. Now there are two more questions, one from Shiva, one from me, actually. So I'm going to quickly ask my question, then we'll get to Shiva's question. And until then, any more questions, feel free to send them in through the live stream. We were talking a little while ago, and this sort of just came up in my mind. We were talking about how beam search isn't very surprising. And if you take a look at like the distribution of probabilities, it looks a lot more similar to human text for us to use nucleus or top P sampling versus beam search, right? It's not, we have really consistent probabilities. It's not surprising at all. Now my question for you is, I was looking at your Twitter this morning, and I saw that you're doing work where there's this idea of being able to do beam search and sampling within the beam search. Can we talk a little bit more about that, or what some of the advantages are?
That's a very specific point. Yeah. Oh, it's. I mean, I mostly think that it's. Yeah, it's hard to say. I mean, personally, I think it's a bit strange to sample inside a beam search because it's kind of not the idea of the beam search. The idea of the beam search is to keep the best beams. So I was kind of wondering if we could just remove this part in the library because we wanted to refactor a little bit the generation, and sampling inside beam search had a lot of complexity because you have two softmax that you need to kind of organize the probability so you can sample across all beams, and then you move them around. But it turns out that a surprisingly high number of people are doing that. So I still need to investigate a bit more what they are doing. That is that just they're using the possibility because they can, or is there some real reason? I think it makes sense to sample beams themselves, but then this is another idea. Then you actually sample a sequence from the model, which is it's a lot harder to do. There is one paper by Max Welling showing how you can do that, but you want to sample like without replacement, or I'm not exactly sure how they do that, but yeah, it's a lot harder. You want to sample like all the tokens at the same time. This is an interesting thing, I think. But like sample each token inside the beam search is kind of a strange way to approach it.
Yeah, interesting. Well, hopefully you can figure out why exactly they're doing that.
If you have an idea on this is still. I find beam search always interesting, but there's so many different work on diverse beam search. There's so many people have been working on that sometimes it's a bit hard to know everything.
Yeah, definitely. Well, it's interesting to see how people are using a feature that we didn't necessarily expect them to use.
Well, we give them too much freedom, but that's the idea.
Well, it's still an amazing package. Okay, so now another really quick question from Shiva. I'm going to expand the scope of Shiva's question here a bit. So her question originally was, how much knowledge or understanding of like cognitive or neuroscience do you really need to leverage and build NLP models? But I'm going to expand that to just generally, how important is it to know a bit about like cognitive or neuroscience to leverage deep learning models in general?
Oh yeah. Yeah, that's a good question, because I think there is two different things. I think in general, I'm not a huge fan of cognitive analogy with neural network. I
I
think
agree.
often it's just this bad way to explain that in blogs or like a journalist do that. I think if you can refrain from doing that, it's a good practice. A bit like you, if you can refrain from giving attention to your model, saying, "Oh, my models want to do that," it's also good practice not to anthropomorphize all this model. But if you are like trying to think about how we build these models, like trying to invent new models, obviously it's interesting to have a look at how we human kind of are wired and like to try to understand. Having like yeah, having looked a little bit about neuroscience in the field because of some friends working on this, it's actually very difficult to understand how our brains work. So a lot of things we try to extract are like very noisy signals. So I don't think it's very important. But on the other hand, there is another thing that I think should be maybe more more widely known, is more about like linguistics and like social sciences. I would say just because the NLP models operate on actually human data, which are human generated and have effect also on human data. And if you only take the very narrow view of these are just mathematical models, they just have no, like actually no relation to any social construct, you're missing a lot of important part about the text and the way we generate text. I think it's important to understand, for instance, a little bit about discourse, about how there are like several levels of understanding in the text. There is like the literal meaning, but there is also the meanings you want to convey to the interlocutor, understanding a little bit about speech act, the fact that when we speak, we try to like there is some kind of action. Also the speech model, or like the rational speech act, which is that you say something because you have in your head a model of how your like interlocutor will change his world model in reaction to what you say, and you want actually to bring him to this new world model, which is actually the reason you're saying a thing. So understanding a little bit about that, which is the field of linguistics, basically, is I think very interesting, and kind of open up the box of everything you can do with language and all the things that language can do. And this is very important if you want to do to understand how and why also the models are failing in NLP. We
Yeah.
often think language is very logical, but it's not. There is a lot of context, implying context, and it's really an act of communication. And so reading and knowing more about that is, I think, maybe more important than knowing more about our cognitive science if you work
Yeah.
with NLP.
I completely agree. And, you know, I think what kind of annoys me is that because language, as you mentioned again, is so ingrained in the way that we think, because it's the most, or not necessarily, but I'm going to say this, on a high level, it's one of the most pure ways for us to get a thought across to another human. And because language is so unstructured and so implicit and so contextual, when we say something that doesn't necessarily make sense, when we have to explain language, we use language to explain language, right? It's
Yeah,
again
I agree
inelegant
with
in a
that.
way,
Yeah, yeah.
right? That we've got to use language to explain language. It doesn't really make all that. It's interesting, and that sort of also again adds to the complexity with neural network models, where if we want them to be able to do generally common sense reasoning about the world, suddenly
Hmm?
they also have to learn this whole baggage of representing that reasoning in natural language, which makes the task orders of magnitude more difficult. Because then at that point, the mathematical incentive stops being the reasoning and starts being, just representing the language to represent the reasoning. Right? It's two levels, and neural networks are lazy, right? As we've talked about. So it's very interesting. Thank you for sharing that. Now, two more quick questions. I'm actually going to group these two. So the first one's actually from Gotham on the live stream. He's asking, what do you find more interesting or harder, quantum physics or natural language processing?
uh, they are hard for different reasons. I think coming from physics, this is really what we I would call it like a cold science. Like there is really math and math only, and the math can be just too difficult. Like often, just you just cannot solve the equation. Like they are just too complex. As soon as you don't have just two body or like you have more, like you're just trapped. So the math are really tough. But when you come to AI and NLP, which I think is just not a cold like science, like I would say cold. It's not, I'm not sure it's the word, but like hard science. Yeah, maybe hard science is more the word. There is all this like human social aspect to the data you're processing, and this is the hard aspect, I think. Like language, we fall back and we're like, oh, but it should be logical, and then you look at your data and you're like, this is just not logical, because we're using language for so many, just as you were saying, for so many things. Language is just not the cold logical form we would like to see as a mathematician working in AI, maybe. And this is the hard part, I think, but this is also the most interesting part, in my opinion, that
Yeah.
this is like real data. This is something that is lively, and this is like, yeah, it's very different. Yeah.
Yeah, so they're both hard, but for different reasons, right? And in different ways. It kind of depends on what you're passionate about.
One nice thing about our field is that we can do experiment very easily.
Yeah.
This is something we don't value enough, I think. Or if you only done like research in computer science, maybe you're not aware how hard it can be just to set up an experiment in any other field. Like the tools I was using when I was doing quantum physics can cost 1 million just to build the tool, and then the tools were just so easy to break and just not really wanted to work. And then our experiments, they are so easy to do. You can even reproduce them if you're not sure. Oh, let's run this experiment again. In real life, in any other field, you cannot do that.
Yeah.
We're very lucky, I think. This is an interesting field to do science.
That reminds me of a video from Tom Scott on YouTube a little while ago where he was talking about the fact that we take this for granted today, but unlike just a couple of years ago when we had like typewriters, now we can hit backspace and we can change a character, or we can cut an entire section out of a book.
Yeah.
I'm writing a book right now on the Go language, and the fact that I can just say, all right, I don't want this code snippet here. I want to copy this whole section to the very bottom, and I want to insert a table here. All this thing, we take this for granted, but it's really important. And if we take a look at a similar analogy in quantum versus AI, in quantum, you can't really recreate an experiment. You've already spent the millions of dollars to do the experiment. But with AI, it's like, oh, I'm going to spin up a quick cloud server. It's going to cost me like $40, and I can recreate whatever I want to recreate, right? So it's incredible that we've democratized it that much. And I mean, there's still a long ways to go, right? Like there's still TPUs can definitely be cheaper, but at least we have that ability to be able to do so. All right, now, so an extension to this question really quickly, then we're going to get to Tim's question, and then I'm going to ask you one more thing. So Manas is asking, what kind of math is important for me to know before I enter the world of machine learning tech?
Oh yeah, that's a good question, I think, because you should know some math, definitely. So I would say linear algebra is very important, because this is the basics. And then you need to know a little bit about, how you call that, derivative, and like all these partial equation, like partial differential equation, to know a bit. And then me personally, I did study a lot of probabilistic thing, because I thought I was not good enough in some probabilistic aspects. So I think this is important as well. Probably will be in the future. So this is the basics. And then I think it's also good to learn a bit about the old AI technique. Like if you can read like a modern approach to machine learning, something like that. If you know the A-star algorithm, just know what all the people have been experimenting with, just the Bayesian networks, everything like this. It's also, I think, good to know what people have been playing with, what they've been trying with, what they've been trying. Yeah.
Looking into the past can help you peer into the future even more accurately.
Yeah.
Right.
And not inventing the wheel all the time.
Yeah, like, exactly.
Oh, sounds good. Yeah.
That kind of, again, which is why it's amazing that we have packages like transformers. No one's reinventing the wheel, re-implementing the entirety of the word piece tokenizer. No one's doing that, right? Re-implementing beam search. You just got a single standardized optimized implementation from the open source community, which is amazing. Right, so now a question from Tim Duncan before we end today. He's asking, how can we collaborate with your teams, the Hugging Face team, on open source work?
Oh yeah, but it's very easy, because open source is open by nature. So you can open a PR. So in the beginning, it was a bit sometimes hard to like discuss open thing. Like people were a bit scared to open an issue. So right now we have a forum, discourse forum since 2 weeks now, which is really active. So it's nice. So you can just ask here, you're like, okay, I would like to participate. I have this idea. What do you think? Is it worth doing a PR or pull request? And then people will say, oh yeah, that's interesting. Or we will maybe we say, okay, but we're already working on this. Maybe you can join the effort. Or like, yeah, it's very easy. So the easiest way is probably just to open a thread on the forum and just say what you want to do. And yeah, yeah, we're very happy to welcome people to participate. There is like I think 400 contributors already to the thing. So we have a contributing section or thing like that where you can find help, because obviously in the beginning it's kind of scary, I guess, to contribute to a big repository. So we have things to explain how you should do, how to like clone the thing, how to open your pull request, and thing like that. We can guide you. Yeah.
Very interesting. It's nice that you have a discourse. People can communicate, they can talk, they can discuss different sorts of things without having to necessarily go to GitHub, start an entire issue. You're right. Some people can be hesitant when opening up an issue on a repository that so many smart people have worked on. You're like, does my issue really matter? Is this really an issue that we want people to see, right? But I would say that don't be hesitant, right? There have been many cases where I'll open up an issue on GitHub and I'll be like, oh wait, never mind. No, this was just an error on my end, right? But the GitHub issues are there to help the rest of the community figure out that, hey, that's an issue that needs to be fixed, right? So that's I would say it's really nice that it's open source. Leverage the fact that it's open source and work towards making it better for yourself and everybody else, right? So it's
you can just keep in mind that we are a small team, so sometimes it just takes some time to reach your question or to reach your PRs. We just we do what we can, but
I understand. It can be overwhelming. I will say, even with a large team, to look at all these different PRs and issues being opened, and but yeah, it's wonderful that you're doing this. Thank you for that, and also thank you very much for being on the show today. I really appreciate your thoughts. I'm sure the audience has had an absolutely wonderful time today. I mean, we had an amazing discussion. I've learned a lot about the world of NLP. I'm sure everybody on the live stream has as well. And before we end the episode, is there a closing message that you want to share with the audience as well?
I think the closing message is just maybe the last question was good. I think just don't hesitate to participate. We are a community-based company. I think we have a closed Slack, but we invite some people we work with, and like yesterday I was looking, and I think we have like 120 people on our Slack just for a team of 20. So collaboration is so deeply ingrained in our DNA that we really love to work with people. So if you have a good idea, if you want to participate, just don't hesitate to reach out. We'll be very happy. This is the way we see, AI going forward in the future. And I hope if there is an AI winter, I don't hope there is an AI winter, but I hope that if sometime there is less hype and it becomes a bit quieter, then the thing we'll keep is this cooperation, open source, open sharing mindset, and I hope we can also extend that to other fields. Like say, okay, some stuff, everything can basically be free, and just the science is better, and just everything is better this way. So
absolutely. Advancing.
I'm very happy.
Thank you. I mean, I completely agree with you, right? Advancing what we can do as humans is possible when we collaborate with each other, when we cooperate, right? That's what sets us apart. And when we really use that ability of ours to come together and not just have the ability of like a single human mind, but like, as you mentioned, for a team of 20, having 120 people on Slack, putting together all these different really intelligent people and being able to put together those thoughts is really incredible. That's why open source is such an amazing technology, right? And I mean, first of all, your thoughts on natural language are really, I think, pretty incredible, right? The fact that we've seen today how deeply ingrained natural language is in the way that we think, right? Taking a look at what the limitations are, just because when we start to see neural networks that generate language, we start to think of them as intelligent or human, because that's how we communicate, that's how we represent thoughts, right? So we start to see intelligence where there is none, right? And the fact that a lot of people word this as AGI, or that models, we even use language that sort of humanizes these models, right? This model realized this through gradient descent, even though that isn't really accurate. That's a fundamental limitation of our language. Again, we don't really have words to represent what we're trying to get across in a simple way. So these are all different challenges that we're going to be working towards solving, and I think that your thoughts have really helped us get a clearer picture of what the future of NLP looks like. So thank you for that, Thomas. And also thank you to everybody joining the stream today. I really appreciate you joining in. Remember, these streams are held every morning in the every Sunday in the morning Eastern time at 11 a.m. EST. Now, next week, again, we've got some really exciting content lined up. Again, compiler technology, which is what I'm really passionate about. I'm not going to tell you too much just yet. You're going to have to hang on for a couple days before I can tell you more. But I will tell you that our special guests have been responsible for building some really incredible compiler tech that's really defining the future. So thank you very much, Thomas. Thank you, everyone, for joining in today, and goodbye.